Example 4, finding the domain of the quotient of these two quadratic equations. So of course, for any quadratic equations, we know the domain of any quadratic equation is going to be all real numbers. So the domain for both of these functions are from negative infinity to positive infinity. Now let's go ahead and find the quotient f over g. Well, f of x is 5x squared, and g of x is 2x minus 3 times x plus 1. And of course, I factored it out beforehand for the convenience of doing the work and to keep this video short. And I don't think we can simplify any further, so this completes the simplification process of this quotient. And of course, we can tell right away that we have a rational expression here, so we had to exclude all of the x values that would make the denominator become 0, because otherwise, if the denominator is 0, then the whole thing is going to be undefined. We don't want that. So take the denominator and set it not equal to 0. Use the zero product property and set each of these binomial term not equal 0 separately. And of course, if we add 3 right here, we're going to have 2x equal to 3. Solve for x by dividing both sides by 2. We have x cannot be equal to 3 over 2. Solving for x here by subtracting 1 to both sides, we get x cannot be equal to negative 1. So these are the restrictions of this quotient. And of course, we don't have any restrictions from the domain of f and g, so we're good on that. So let's go ahead and find g of x over f of x, which is just going to be 2x minus 3 times x plus 1 all over 5x squared. And we have another rational expression here, so we have to exclude all the x values that would make the denominator 0. So we take 5x squared, set it not equal to 0, divide both sides by 5. You get x squared cannot be equal to 0. Take a square root of both sides. To solve for x, you get x cannot be equal to 0. So this is the restriction of this whole simplification process. Now let's go ahead and graph the domain of both of these on the number line. So we have the number line here. And let's see, for f over g, well, we got negative 1 and 3/2, so maybe negative 1 here. And I'm going to put 0 right here. And maybe I'm going to say 3/2 is over here. So the domain of the function f is the same as the domain of the function g, which is all real numbers. So it's just a solid line like that. However, as mentioned, in the quotient f over g, we have x cannot be equal to 3/2 and x cannot be equal to negative 1. So at x being at negative 1, we're going to put an open circle. At 3/2, we're going to put in another open circle. And of course, remember that the open circle goes with cannot be equals to. And of course, it also goes with strictly greater than or strictly less than. Just for a quick reteach. So that means the domain of the quotient f over g is going to include all of the x values in common of both domains of f and g, and all of the restrictions from the domain of f, from the domain of g, and from every step of the simplification process, which are just these two restrictions. So we have the graph of the domain of f over g looking something like this. So how do we write the interval notation? Well, from left to right, from negative infinity up to but not including negative 1. So we're talking about open interval, negative infinity, comma, negative 1. Put the union sign to go to the middle part. From negative 1 up to but not including 3/2, and of course not including negative 1 either. So we got negative 1, comma, 3 over 2. Put the union sign to go to this part. From 3/2 but not including 3/2. all the way to positive infinity. And this is the interval notation for the domain of f over g. So again, the domain of f over g is all real numbers except x cannot be equal to 3/2 and x cannot be equal to -1. Now what about g over f? In g over f, we have that x cannot be equal to 0. So I'm just going to put 0 right here. Same as before, domain of the function f and g are the same, which is all real numbers. Cannot be equal to 0 as a restriction. We also don't have any restriction from the domain of f and from the domain of g. So to limit saying of course, because I like to say that a lot, I'm just going to go ahead and sketch the graph of the domain of g over f, which looks something like this. Now what about the interval notation? Well, going from left to right again, from -infinity up to 0, but not including 0. So we're talking about the interval, the open interval for this part of the graph of the domain of g over f. -infinity, comma, 0. Put the union side to go to the next part. We go from 0, not including 0, all the way to positive infinity. And that is how we find the domain of g over f.